We are continuing to find other angle measures, and what it means by other angle measures is that we are not talking about a central angle or an inscribed angle. So this is actually day 2 of the other angles. So we're going to calculate the measure of an angle formed by two chords this time. Now, we've already done two chords when we did inscribed angles. So when two chords come together on the circle, we know that an inscribed angle is half the measure of its intercepted arc. So we know the measure of angle ADB is half the measure of its intercepted arc AB. So when we say we're finding the measure of an angle formed by two chords, it is not that. It's something else. So before we go on to today's lesson, let's go ahead and review what we've learned. We've done a central angle, so at the center. We've done on the circle by inscribed, and we've done on the circle but not inscribed. The central angle and the minor arc are rotating at the same rate, so the measure of the angle ACB is the same as the measure of arc AB. So the central angle and its minor arc have the same degrees. An inscribed angle is half the measure of its arc, and even though this angle is not inscribed, it is still on the circle. So the measure of the angle, the measure of angle ADE is half the measure of the arc that it intercepts. So in this case it's arc AD. Since there is a B in there, like if you really wanted to get crazy, you could say the measure of arc ABD. But because we're not going the long way, we don't need the B. So our new theorem today is two chords intersecting not on the circle, but somewhere inside. So then the question becomes, well, how is this different than central? Because it's anywhere inside. It could be inside really close to the edge of the circle. It could be inside at the center, but at that point we already know what to do. So it could intersect anywhere inside. Now we know vertical angles are congruent, so we know these two angles are congruent. So the misconception is that these two arcs are congruent. Now I purposely made this example visually so that you can see that this is definitely not congruent to this. This is bigger and this is smaller. Yet these two angles are congruent, so how in the world does this work? What we're going to do is we're going to average them out. So we have something big, we have something small, we need something in the middle. So the measure of our angle is going to be the average of these two arc measures. So average means to add the two together and divide by 2. But you know me, I like consistency. So since we've already started with a half, we're going to stay using a half. So half the sum of the two angles half the sum of the two arcs that the angle intersects. So angle 1 is dealing with arc AB and its twin is dealing with arc FD. So that's how I know which two arcs to use. And again, this is an average. We're adding the 2 and divide by 2. I just like to stick with the half since we already had a half. So we have center, which is exactly the same, on, which is half the arc, and inside is half the sum because we're going to average it out. So inside is half the sum. So let's just do a little review. This is an on question. So if it's on, we know that the angle's measure is half the measure of the arc it intercepts. It's intercepting this arc right here. So we're going to multiply by 2. So 236 degrees is the value of y. And that is because we're rotating faster out here than we are around the point. Now number 2 is an in. And again, we can't assume that this is 89 degrees because we cannot assume that this is in the center. So we're going to average out the 2 arcs. So how do you know which 2 arcs? So 89 degrees is the angle we have. So the arc that goes with that angle is x, and the arc that goes with its twin is 63. So we're going to add the 2 and divide by 2. So half the sum. So the angle equals half the sum of the 2 arcs. In previous lessons we've talked about, well, what do you do with the half? We can distribute the half, but most of us probably aren't going to do that because 63 is odd. It will not distribute nicely. So I'm going to go ahead and multiply both the right side by 2 and the left side by 2. That gives me 178 equals x plus 63. Remember, the half and the 2 cancel because that's what we were doing on purpose. We chose to do that. So now we're going to subtract our 63, and that gives us 115 degrees. So this arc is 115 degrees of the entire circle. And you can double check that. 115 and 63 is 178. When you cut 178 in half, you get 89. So when you average them, it's working out. So the first 2 questions had x's and y's. B has a 1. Now 1 is not the value. 1 is the name. So I'm not asking you to find a variable. I'm asking you to find an angle by name. So the way you write it's a little differently, but the process is still the same. The angle goes first, and it is half the sum of the 2 arcs, or we're averaging out the 2 arcs. Which 2 arcs? Well, angle 1 has arc 140, and its twin has arc of 116 degrees. So those are the 2 that we're going to average out. So we're going to take half of 256. So the measure of angle 1 is 128 degrees. And then our last example is back to solving for x. It's been rotated, but again, it's inside. We do not get to assume that that is the center. 115 degrees is cutting out an arc with x degrees. Its twin is cutting out an arc of 105 degrees. So the angle 115 degrees is equal to half the sum, x plus 105. So again, we're averaging them. Add the 2, divide by 2. Again, as in our previous example, you probably don't want to distribute your half because that's an odd number. So I'm going to multiply by 2, so that gives me 230 degrees. When I multiply by 2 on the right side, the half cancels, so x plus 105. So now I'm going to subtract 105 from 230 and get 125 degrees. So this arc right here is 125 degrees of this entire circle.